Any group is already ready for the presentation?
We are ready to present today, but I thought to be the second group
Okay, it's
because
fine. Look, anyway, we have with us Dr. Manar Younes. Dr. Manar is a PhD student in AUB and she graduated just in this spring. And she is taking a teaching course in AUB. So we will give her the opportunity to give us a presentation on the final chapter, which is economical analysis. So Manar will give us now a presentation and then we can ask her questions. So you can ask questions during the presentation. And after this, we can continue your presentations. Okay. So the presentation of Manar will be related to our course content. And I will do problems with you on this chapter next time. Okay. So the floor is open for you, Manar. I will, you can try to share your screen. So I will allow you to share just 1 minute.
Doctor,
Yes.
احنا we have a presentation today. Do you want us انه بعد lecture او
Yes.
انه at the end of the lecture قصدي؟
Directly after the lecture will not take a lot of time. I think less than 1 hour. So after the
Okay, deal.
lecture, you can do your presentation. Okay.
Okay, deal.
Yeah. So Manar, can you please try to share your screen?
I'm still not able to share my screen, Dr. Karim. You cannot start sharing. You are sharing
Okay.
your
Okay.
screen.
Yes. Yes. I will stop. Yeah. Let's try to do it.
Yeah. Okay. Thank you. Okay. So it's working now. Thank you.
Okay.
So hi everybody, and thank you, Dr. Karim, for presenting me. Today I will be giving you the last chapter that Dr. Karim was supposed to give you. It's regarding the economical evaluation of renewable energy projects. So every project, even if it wasn't a project related to renewable energy, it should be assessed at the final stages. It should be assessed. So this assessment is divided into two parts, mainly economical, because most clients and most people care more about the economical part. They always want to save money. Okay, and we can assess or evaluate our project, especially because it's a renewable energy project. We can assess it in terms of environment. Okay, so in terms of evaluation, we have two types of performance evaluation. So first of all, we have the environmental performance, and we can assess the project using the life cycle assessment method, which depends on the calculation of impact indicators from energy and material reflex inventory during the life cycle of the project. Okay, we have another method. These methods, the environmental performance, are only for your information. We will be focusing more on the economical performance. Okay. So we have another method, which is called the carbon accounting method, which takes into account the direct and the indirect greenhouse gases emissions accounting for a given entity. So the direct greenhouse gases emissions, we know them, like the emissions from the, for example, from a vehicle, or if we are talking about a plant, electrical plant, the emissions that are emitted from burning fuels and so on. But does anyone have an idea what are the indirect greenhouse gas emissions are? What do you think? Direct, okay, نعرفهم اللي هن emitted directly and we can see them. But the indirect, what do you think? Does anyone have an answer? You can send your answers in the chat box, okay? So we have two types of greenhouse gas emissions. We have the direct and the indirect. And finally, we have, regarding the environmental performance, we have the ecological footprint, which compares the human resource consumption and waste generation, the consumption of the resources plus the waste generation that results from this consumption, to planet Earth's ecological capacity to regenerate the sources for the future generations and to absorb waste. Okay, and it's generally expressed in unit area for a given population. Okay, now مثل ما قلنا what we care about the economical performance. Okay, so in order to assess any renewable energy project or any project in terms of economical performance, we have three methods or three indicators. Let's say indicators. Okay, so first of all, we have the life cycle cost method, the LCC, life cycle cost method, which depends on evaluating the cost during the entire life cycle of the project. Okay, على كل اللايف سايكل that's supposed انه هذا البروجكت يخدمنا بنعمل cost evaluation. Okay, we have another index or indicator or whatever you want to call it, which is called the net present value, the NPV, the net present value. Okay, each method or each indicator راح نشوف كيف راح نحسب كل ال variables يلي فيها. So the net present value, it depends on the profitability or it indicates the profitability of a project. يعني احنا كيف بنعرف إذا البروجكت عم يربح معنا أو عم يخسر. You have to calculate the net present value. We will see it later on بالslides if it's positive, if it's negative, إذا في عنا كذا condition لنعرف إذا البروجكت is profitable or not. Okay, and you should always compare it to a reference. راح نشوف كمان later on شو هو هذا الريفرنس يلي we will compare our project to in order to know if it's profitable or not. Finally, we have the CER method, which is called the capital enrichment rate, and it is used to analyze the profitability of a renewable energy projects. Okay, but we should take care that these methods are based on numerous parameters. They have many parameters that should be taken into account. Okay, so it's difficult to check the validity of each parameter, and some data are missing and the corresponding parameter is set by default. Okay, راح نشوف later on إنه في values or parameters راح ناخدهم like default values or assumptions that should be taken into account. Okay, كمان regarding the assumptions, we will take many assumptions in order to simplify our calculation. Okay, sometimes they are arbitrary or subjective, and the results depend on these assumptions. The results اللي راح تطلع معنا regarding مثلا إذا حسبنا ال NPV, net present value, or the life cycle cost, they will depend on the assumptions that we will make. Okay, so these assumptions, we should select them precisely, and they must not be exposed without these assumptions. Okay, and generally absolute results are less relevant than relative results because several variants can be compared. Okay, regarding the ecological assessment, environmental assessment كنا عم نحكي فوق هيدا, this map represents the example of the ecological footprint for the countries of the world. Okay, footprint which is expressed in global hectares per capita. Okay, so بنشوف إنه شوفوا مثلا هون the states. Okay, عندها the highest ecological footprint. Okay, بينما هون مثلا أفريقيا شوفوا الvalues تبعيتها they vary pink و red تقريبا, they vary between 2 to 3, 6 to 7 تقريبا between هول values. Okay,
May I ask a question, please?
yes, شو تفضل.
What does it mean to say that the footprint is in hectares per capita? Like each person, how much hectares is it affecting, or like
hectare, yes, in terms of area, per capita, per population يعني.
كل إنسان قد إيه عم يأثر على مساحة من الأرض يعني بهالمعنى يعني.
Yes, what do you think, Dr. Karim?
Okay.
Yes, exactly. Yeah.
Okay, تمام. So let's start by أول topic عنا إياها بالeconomical assessment اللي هي life cycle cost. Okay, so in the life cycle cost we want to answer these questions. How much will the project يلي نحن عم نشتغل عليه, how much will it cost and how much will it pay? Okay, and which solution will be more profitable. بالعادة نحن لما نكون عم نشتغل energy projects and so on, you put many scenarios. How do you select the most profitable or the most convenient scenario? You should, in terms of economical, عم نحكي هلا economical assessment. Okay, نسول الفوتبرنت والCO2 footprint وكل شيء خاصه بالenvironment. عم نحكي economical assessment. So you should make, in terms of economical assessment, you should calculate some values in order to indicate that which project or which scenario is most profitable for us. Okay, so بالعاده you accountancy of monetary flows يلي انت بتشوف شو الانبوت عندك بالبروجكت وشو الاوتبوت يلي راح يطلع معك. you decide the unit of your which rate or which currency راح تستعمل أنت يورو dollar pound Lebanese lira whatever. You have a limit of a simple accountancy, which is time is not taken into account. Okay, but lifespan of the project can be long. For example, for a building, the lifespan it's important to be taken into consideration. In most calculations you take the lifespan of your project or lifetime تبعه. Okay, so for example, for a building you take its lifespan between 50 to 100 years, and for an equipment you take this lifespan between 20 to 40 years. What do you think regarding the lifespan? كل ما زادت اللايف سبان تبع البروجكت شو ممكن, is it good or will it be reflected negatively on our project? What do you think? How you take time, or in other words, how you take time into account. مثلا مبنى عمره 10 سنين ومبنى عمره 30 years. Which is better? What do you think? إذا نحن بدنا نعمل project, which is more economic, more profitable, and why? هيك, like roughly speaking, what do you think?
No, the older building will need like maintenance.
Exactly.
كل الوقت. So it will cost more.
Yeah, cost wise it's not profitable. راح يكون زي like added cost لإلنا. اوكي, لانه رح يتعب المبنى, رح يصير في عندنا maintenance and more operational cost and so on, so it will not be profitable. Okay, so we should take the lifespan of any project.
Just one comment, Manar.
Yeah.
Yes, it's true that with time the maintenance will increase, but in case, for example, if you are considering a building where you have a resident building, then you should have a long lifetime for it, because if it will just have a lifetime of 30 years, no one will buy something in this building.
Yes,
okay,
yes.
So look here, it's true, you have different factors. So for any project, what you can talk about mainly is to have a small payback period. Okay, but for the lifetime, it's good to have a project with high lifetime, because higher is the lifetime, better. And if you want your project will be viable for a longer period, and then it's true that maintenance will increase with time, but also the profit from this project will increase, because any project will give you back money. So if it has a long period of time, it will give you also a plus. Okay, so we have here two things. It's maintenance from one side and costs from the other
We should
side.
optimize, right?
Yeah, all right, of course. Okay, but anyway, it's if you want your example is right, just take other than a building. So you can take example, for example, let's say a turbine. Maybe for a turbine, if you consider a very long lifetime, the turbine will not operate good after, and it's true that at a certain moment you will pay in a maintenance more than you will get. In this case, it's very true, but just the example maybe was not very appropriate.
Yes.
Okay.
Yes. Thank you, Dr. Karim.
Welcome.
So regarding time, how we should take time into account, we have 3 parameters that describe the time evolutions. Okay, we will be راح نتعرف عليهم هلا. First one is the interest rate. The second one is the inflation rate, which is the consumer price index, and the last one is the discount rate. Let's get to know each parameter by itself. Okay, بعدنا هون عم نحكي عن the life cycle cost. Okay, so the interest rate, which is represented by I, is the cost of the money. Like the case of a loan from a bank. Okay, you take, the bank set an interest rate on this amount of a loan. Okay, so it must be taken into account in case of loan, and it's set by the banks. Okay, then the second parameter that we have is the inflation rate, which is the consumer price index. It's represented by symbol lambda, and it represents the change in the value of the currency. اوكي, مثل ما عم بيصير هلا in Lebanon, the value of the currency, القيمه تبعت الليره, it changed over the time. Okay, and it's evaluated, this inflation rate is evaluated each year by statistics institutes, which is called the consumer price index. Okay, so بالlife cycle cost تبعتنا, it's inflation rate is assumed to be equal to 0 in case of constant currency. إذا كل الأوضاع تمام والcurrency value تبعتنا is always constant and it's not changing, it's assumed to be 0. Okay, clear? The final parameter that we have is the discount rate, which is called A. It will be used in the life cycle cost method. The basic concept of the discount rate is that it's subjective estimation and is the confidence in future. It represents how much you are confident in the future. Okay, if you think that the conditions in this country will be stable and so on, so the discount rate will be what? If you have high confidence, A will be close to 0. Okay, you should not take it into account. However, if you have low confidence in what is happening around you and you don't think that the value of the currency will stay the same, so you have low confidence in the future, A will be high. Okay, parameter A will be high. Clear? So high confidence in future, A will be close to 0. Low confidence in the future, A will be high. Clear? So how can we relate A to the value, the equivalent subjective value Vn? Vn plus 1, n represents the year n. So n plus 1 is the year next. You are predicting, it's like you are predicting what will be happening next year. Okay, so Vn plus 1 is equal to Vn. Vn is the equivalent subjective value for year n, or you can say the current year that you are assessing in. Okay, multiplied by 1 plus factor A يلي قلنا هو شو like the confidence value. If you have high confidence in the future, A will be close to 0, and if you have low confidence, A will be high. Clear? And A is set as a constant during the project. Clear, guys? Any questions so far? Now we are just getting introduced to these parameters to see how we will yeah. Yes, في حدا عنده سؤال؟ Okay, so كنت عم لكم إنه now we are getting introduced to these values and parameters in order to see how we will apply the life cycle cost method in order to assess any project economically, okay? So the evaluation of the cost of any project of a useful energy generation, okay? The life cycle cost is the evaluation of the cost of a useful energy generation, okay? So it allows the comparison of the cost of several generation means, especially the production cost of 1 kilowatt hour of electricity. Okay, it allows, it allows the calculation of a cost of a production of 1 kilowatt hour of electricity. Okay, so the life cycle cost, LCC, is the sum of the present costs during the system lifetime. كل شيء cost, it relates to all the present cost during the system's lifetime. Okay, lifetime مثل ما قلت لنا دكتور كريم قبل شوي, for a building مثلا 50 to 100 years, for any equipment 20 to 40 years, whatever. Okay, so the general rule of the life cycle cost, which is نرجع بنعيد the sum of the present cost during the system's lifetime, هي عبارة عن sum, so it's the summation from year n, from I equals 0, which is the starting year اللي احنا بلشنا فيها, to n. Okay, n is the lifetime of the system under study, like 20 years, 30 years, whatever. N is the lifetime of the system under study, and I is the starting year. Okay, so life cycle cost is a summation of CI, رح نشوف شو هو CI, divided by 1 plus A. A قلنا شو مذكرين؟ discount rate, which represents the confidence in the future. Okay, 1 plus A power I. هيدي الرول تبعية اللايف سايكل كوست. اوكي سو سي اي, شو هي السي اي؟ هي عبارة عن what؟ سي اي is the cost of the year I, اوكي in constant currency. الكوست تبعنا بالكرنسي اللي نحن عم نستعملها, which includes the taxes والفيز etc. اوكي سو سي اي is the cost of the year I. I قلنا هي A هي discount rate, and if the lifetime of the year under study, and I is the starting year. Okay, I think no, it's fine. Okay, Dr. Karim, is it correct or هون ناقصة minus شيء?
No, here
it's correct.
It's fine. It's correct, the life cycle cost. Okay, after when you want to do the balance, okay, you will take into account
investment
and benefits. So here, when just you talk about LCC, it is just the costs you are having during the life cycle time. After, we will assess the NPV, the net present value. The net
Yes.
present value will represent the balance between the costs and the incomes. Okay?
Okay. So when CI, when the cost of the year is constant over the year, we can use this formula, which is the summation. يعني هيدي إذا كانت constant معنا, we can فينا ما ناخدها into account. So شو بتصير عنا هيدي الإيكويشن شو بتصير بتتغير؟ بتصير 1 over 1 plus A power I. Okay? Or we can say that the life cycle cost شو بصير total equation تبعيتها final equation if CI is constant over the year بتصير life cycle cost عبارة عن ال I, let me annotate, بتصير عبارة عن ال I, okay, plus CI total cost over KA. شو ال KA؟ هات لنشوف بس لحظة. Okay, so life cycle cost بتصير هي عبارة عن ال I is the investment, okay, investment cost plus I plus CI اللي هي عبارة عن total cost or the cost of the year over KA. Okay, guys? So any question?
Just here,
Haida.
Manar.
Yes.
Just here,
K
one
is
comment.
Yeah.
Guys, here, when you have this summation, okay, this is, if you have CI constant, then it's like you are, when you take CI outside, because it's a constant, you will get the summation of 1 over 1 plus a to the power I. And in math, you have that this properties is a geometric series, so you can easily get a certain, this summation from I to N can be written function of A and N. Okay, so because the cost is constant, it can get outside the summation, and that I am left out with a summation that I can mathematically replace by 1 plus a to the power n minus 1 over a times 1 plus a to the power n. This is a formula that you have taken at school when you consider geometrical series. So when you are multiplying, because each year you are multiplying the cost by 1 over 1 plus a. So with years, this means what? This means that the value of your money will not be the same at any time. So you know that in general, A here represents the confidence in future. As time is progress, the value of your money is expected to decrease. And if you have now $100, if you pay it now, you can buy much more than you will buy with $100 after. Okay, this is why, because we are calculating the life cycle cost relative to the to time 0, we divide the cost at each year by 1 plus a over I, because the value of the money will not be the same over years. Okay, so when you are assessing the present cost, you should divide the cost by 1 plus a to the power I, where I represent the number of years. So for I equals 0, this means that it is now, you are investing now. In this case, you have the initial cost of your project. Okay, so let's say it's the investment. This is what Manar talked about. You have the investment at year 0. Then you should add from year 1 to year n, which is the lifetime of your project. You should add the costs for each year. But since you are assessing the cost relative to the present time, you should divide this cost by 1 plus a to the power I. So here, this is an advantage for cost, because if you want, the value of the cost you are paying with time will be lower, but on the other hand, also the benefit value will be lower. Okay, and what is interesting for us, of course, is the income. So the income should be higher than the cost. So this is a disadvantage of time, because with time, the value of our money will decrease. So our project must be very profitable in order to balance the loss of money value with time. Okay. Any question on this before we continue? Okay, Manar, so please continue.
بس كيف بشيل الانوتيشن؟ كنت عم بعمل انوتيت فوق وبعدهم. طيب, I will stop sharing and I will start and I will share again. Let me try it. Okay, ماشي الحال. Okay, so let's take an example for the life cycle cost, a wind power generation system. Okay, It's approximated that the lifespan, or it's taken into like an average, the lifespan of a wind turbine is 20 years. Okay, and in terms of electrical production, in terms of its specifications, sorry, we have one turbine of 3 kilowatts. Okay, it's considered as a domestic wind turbine. Initially at year 0, okay, initial investment is 4,000 euros per kilowatt. Okay, at year I, we have usually we have the yearly operational cost يلي هن الفيول بالعادة, and we have the yearly maintenance cost. Okay, at year end total number of year هيدا ما حددوا لنا اياه بس whatever المفروض بيكون 20 years. So at year end we have the salvage value to be deducted. Okay, so عنا I الانفستمنت اوكي هي عبارة عن السي او اي. اوكي الكوست عنا
Sorry guys, just let us wait 2 minutes because maybe Manar is facing some connection issues.
Miss, after the presentation, you will explain, or can we present?
Oh, it's 6 يعني أكيد it's electricity. يلا guys, just 2 minutes, okay? Thank you for your time. If you want guys, meanwhile, if you have any questions on what was presented, you can ask me. And anyway, the explanation of this is already done by me, so you can see also the recorded videos. Everything is re-explained again, so if you can see the videos again, and in case you have any questions, we can tackle them next time before starting the problems together. Okay? No, for the final, you just have the part after the exam, so it will not cover everything because the material is little bit huge, so I don't want to give you a lot of load. So for the final, you are responsible for the part covered after the midterm. Okay. No, look, today we will not have time for all, maybe 2 more or 3 more presentation maximum. But as I told you, for the groups that did not present yet, you can tell me for the time that is convenient for you. We can do it this Saturday or any time during next week when you are available. Just tell me and we do it. Okay? Yes, we will go for presentation next, of course. Just Manar is joining to continue this lecture because she wants to present it since she has a duty for the teaching course she is taking in AUB. So when we are done with Manar, we can continue together with the presentations, okay?
Dr. Karine, I can wait, it's fine. إذا في حدا مستعجل, it's fine, I have time.
لا, it's fine, Manar, it's fine. You can continue.
طيب okay. Shall I continue from here? Wind power generation.
Yes, from where you stopped. Yes.
Okay, so كنا عم ناخد example regarding the wind power generation. Okay, so قلنا initial investment هي we can represent it by I or COI, well yearly operational cost it's O, operational cost, and yearly maintenance cost it's usually calculated as 0.033% of the initial investment in I. Okay, 0.03 multiplied by COI. Okay. So we can write the life cycle cost equation be another representation taking all the factors into account. Okay, يلي هي I شو قلنا هي I initial investment. Okay, plus summation from I equal 1 to n number of the years less CI هيدي E plus CIM. Okay guys, divided by 1 plus A شو قلنا هي عبارة عن what؟ مين مذكر؟ ال A هي عبارة عن في حدا عم يحكي بالشات بوكس. اوكي قلنا الكونفيدنس اور بالفيوتشر ما هيك كل ما كانت زيرو كل ما كان عندنا confidence بالفيوتشر باور I anyway minus CNF which هي the salvage value to be deducted divided كمان by 1 plus A power N. Okay, and the number of years. Okay. So here the production cost between 0.1 and 0.13 euro per kilowatt hour for an assumed when we substitute these values 20 years the turbine domestic wind turbine it has 3 kilowatt hour and the initial investment هو عبارة عن 4,000 euro per kilowatt. When you substitute these values بيطلع معنا إنه production cost is between 0.1 and 0.13 euro per kilowatt hours for an assumed yearly generation 7,500 kilowatt hour per year production cost. Okay, هذا production cost أخذناه like an assumption إنه 0.1 between 0.1 and 0.13 euro per kilowatt hour. Okay, so بيطلع معنا generation yearly generation 7,500 kilowatt hour per year. Yes, any question before we move on to the net present value? Clear guys? طيب we have another indicator to calculate or to assess our project economically. عندنا الانديكيتور الثاني هو كان النت present value. Okay, ال NPV. The net present value is used to evaluate the future value of the projects. Okay, so it allows the comparison of the future value of different or several scenarios ممكن يكون عندنا إياهم. Okay. So ال NPV بالعادة هي عبارة عن السم net present value هي عبارة عن السم of the present cash flows الكاش فلو اللي هو عبارة عن الانكم قديش عندك income minus الكوست يلي عندنا إياهم. Okay, over the observation time. So mathematically mathematical presentation تبعيتها ال net present value هي عبارة عن summation from I equal to 0 current أو current time اللي عندنا إياه نحن مطرح ما نحن we are assessing the year that we are assessing in from I equal 0 to I equal n. N is the number of years. Okay, or the observation time هم نسميها. Okay, so it's RI يلي هو الانكم قلنا نحن انه هو الانكم minus cost ما هيك. So RI هو الانكم or revenue for year I. Okay, اليونت تبعتها اكيد it's currency minus CI. CI هو كل شيء cost عنا اياهم or fees for year I for a specific year. Okay, divided by 1 plus A power I. قلنا ال A هو discount rate which represents the confidence in future. Okay, so هيدا term RI minus CI بنسميه نحن الكاش فلو. RI اللي هي revenue or the income, CI اللي هي cost or the fees. The difference بيناتهم is called the cash flow. Okay, so كيف نحن بنعرف إذا البروجكت عنا profitable or not؟ هيدي value of NPV. If it is greater than 0, then our project is أكيد profitable. If it's less than 0, then it's not profitable. Okay? So let's take كمان الexample اللي كنا عم نحكي عنه قبل شوي الwind power generation. Okay, let's calculate the net present value تبعيته. اوكي سو قلنا هي عباره عن what another presentation هي RI اللي هي الريفينيو divided by 1 plus A اللي هي discount rate power I minus اللايف سايكل كوست. اوكي سو فينا نستعمل هيدي الرول وفينا نستعمل هيدي الرول. اوكي جايز اور كمان اذا بناخذ نحن الاي، شو الاي قبل شوي اخذناها ما هيك؟ شو الاي؟ وين الاي؟ مذكرين شو الاي؟ هيها كانت الانفستمنت ما هيك؟ اذا بدنا ناخذ another representation net present value for year end هي minus الاي الانفستمنت بلس summation للكاش فلو اللي عندنا اياه RI revenue minus CI الكوست divided by 1 plus A discount rate okay or discount value power I plus CNF. شو CNF قلنا؟ divided كمان by 1 plus A power N is the number of years. شو CFN؟ كمان قبل شوي أخذناها بالإكزامبل يلي قبل. what's CFN؟ salvage value to be deducted. Okay guys, clear? So for year I إذا بدنا نشوف الانnual incomes اللي عندنا إياها electricity sale in terms of electricity sale. TS what's TS؟ بدنا نشوف هيدي الريليشن. TS represent the selling price of electricity which كمان هو price يعني له currency. Okay. P is the nominal power of the wind turbine اللي كان عاطينا إياها قبل شوي. NH هيدا الترم هو عبارة عن شو؟ NH is the equivalent hours of operation at nominal power. Okay, so we assume in case of wind power generation عم نحكي عن wind turbine the equivalent hours of operation تبعيتها at the nominal power يلي عطينا إياها بيكون هي عبارة عن 2500 hours per year. It operates at it operates 2500 hours per year. Okay, so بيطلع معنا هيدي الهدول RI. Okay, شو ال RI؟ شو قلنا هي ال RI؟ revenue ما هيك or الانكم. income أو revenue هي عبارة عن TS multiplied by P multiplied by NH. بنرجع بنعيد TS is the selling price of electricity, P is the nominal power of the wind turbine, and NH is the equivalent hours of operation at the nominal power. Okay, in case of wind turbine we assume that it's 2500 hours per year. Okay, per year. Okay. Regarding the selling price and the productivity on the wind turbine may vary أكيد from year to year. Okay, so in some countries there are obligations to buy with fed-in tariff. شو يعني؟ the first 10 years مثل مقطوعية كأن مقطوعية. The first 10 years ببيعوهم ب 8.2 cents والله per kilowatt hour. Okay. The next 5 years inferior or equal بيصير في عنا كمان correction value because of the inflation. Okay. Beyond ببطل في خلص guaranteed selling price. The price that they set, okay, that the country sets لازم ال buyers or اللي عم بيتعاملوا بالwind turbine يلتزموا فيه. Okay. So let's see an example for the net present value. Okay. شوفوا هيدا الجراف. It represents number of years على ال x-axis net present value. Okay, as a function of the number of years. Okay. At شو at different discount rate. شو هو الديسكاونت ريت؟ شو قلنا هو الديسكاونت ريت؟ ال A ما هيك؟ دي اللي هو related ل how much you are confident بالوضع يلي عندك as it's approaches zero يعني بتكون انت so confident. كل ما زادت عنا بتقل الكونفيدنسي. اوكي؟ سو شوفوا هيدا البروجكت اللي عنا اياه مبلش ليكو wind power generation. النت بريزنت فاليو تبعه كان minus 12 thousands وعم بيزيد. اوكي هلا شوفوا كيف